things in here. I've seen if there's anything. Yeah, there's some other letters. This is C, this is D, this was E, and this point right back here was B. Okay, I think I have everything labeled. And we know that, oh, one thing left, this length from here to here was 4, this length from here to here was 6. So this is what was given to us, and we need to calculate the surface area of the entire thing. Oh, and they've also got little squares here. So there's a little square here saying that between this side and the slant height is 90 degrees, and there was a little square there saying that that is a perfect 90-degree angle as well. Okay, so if you want to find the surface area of a shape, sometimes it's nice to sketch all of the shapes that you're going to have. And I'm going to highlight a word here. This question says we want to draw its net. The net of a shape is like if you took a cardboard box and opened it completely up so that it could lie flat. What you're looking at when it's flat on the ground would be the net of that shape. So basically what I'm going to do with this shape is I'm going to say, well, there's a rectangle on the bottom. No. There's a rectangle on the bottom. And if I cut it and opened it up, it would look like this. So one of the skills that we develop in mathematics is a shape skill. Can we visualize taking a pyramid and then unfolding it flat? Does this make sense to you that if I folded these two sides up and these two sides up, that I would get this three-dimensional pyramid to end with, right? So we want to be thinking about shapes that way. That's a skill that we have to develop in our brain to be able to see. Some people can see that super easily. For other people, that's a bit of a challenge, and we have to practice it, okay? Now, what do I know about this? I know this length is 4, right? Because that's here. And this length is 6. Are you okay if I then write, and I'm going to write all of my areas in purple. The area of that rectangle is 24. If we want to find the surface area, we have to find the areas of all of these shapes. So I've got the rectangle, that was the easiest. Now I have 4 triangles. And this is sort of how we problem solve through a question like this. I'm like, okay, well, I still need to find the area of these 4 triangles. If I want to find the area of a triangle, I need base times height divided by 2. What's the problem with my diagram right now is I don't know any of the heights. So this is where I'm going to color code things. And if you have different colors, you might want to color code as well. Okay? I'm going to, on this one, this dotted line, I'm going to put up in blue. That blue dotted line then would show up on this net right there. Oh, there was one other thing that was labeled that I forgot to label. On yours, you have that this is 8, right? Is the blue line 8? No. Number one mistake that students will make in this question is they're like, oh, I need a height. This is a height of my pyramid, but the blue line is a slant height. So now I'm going to have to go back to some grade 9 math to figure this out. With that blue line, I'm going to connect it over to here and up to here. And I want you to notice that that makes a right angle triangle. And in that right angle triangle, you know both of the legs, which are the sides of a right angle triangle, but not the hypotenuse, which is the blue line on our net that we want to find. Okay? Can you tell, does it make sense to you that this blue line here is going to be the same on this side? So that's something we're going to need to find. We're going to do that in a bit. But looking at my net, I also need to find the height of this triangle and the height of this triangle. And the question is, do they have to be the same? Will they be the same as the blue line, or could they be different? Okay? Imagine this is a rectangle where this side is 6 and this side is 4. Because this side is 4, does it make sense that you'd have less distance to go than this diagonal has to go there? In fact, sometimes in math, if we're unsure things are different, we can sort of manipulate the situation and say, well, what happens if this was 4 and this was 600? The 4 sides would fold up pretty quick, but the 600s that are so far, for them to come to the same point would be a lot longer of a distance. Sometimes we can't tell if things are different when the numbers are close. So a good mathematical strategy is to extend something extreme. And say if I had a rectangle where it was a kilometer this way and only a centimeter this way, I made a pyramid. Flipping these sides up wouldn't be very long. But going all the way out to that kilometer and bringing that triangle back to the center would be a long distance that I would have to travel. So, I'm going to color code in a different color this slant height, which I will label it in green on here as well. So you'll find if you have different colors, you can help your brain, because you're going to read this question again to study, because it's one of the harder ones that we're going to do. And if we've color-coded it, it's going to be easier to understand where we're getting our numbers from. And again, we don't know that slant height, but it makes this right triangle here with the actual. And just like before, this other one here is going to be identical. So mathematically, sometimes the first thing you're doing is just sort of analyzing your question and seeing what do you know and what don't you know. And then we go about finding what we need. I need this green dotted line. I need this blue dotted line. So I'm going to start with my blue pen because I'm going to find the blue dotted line. And I'm going to write blue. You can say whatever color. Or if you don't have any colors, first find the blue slant height. And the blue slant height, the way that I've drawn it here, makes a right angle triangle with the actual height. I know that the actual height is 8. In this blue triangle, how far is it from here to the center? Does it make sense that if all the way across is 4, that from here to the center will be 2? And I'm going to call this B because it's blue. You can choose X if you want. Doesn't matter what letter. But I'm just picking B because it's blue. This is a right angle triangle. You know how to use a squared plus b squared equals c squared. So in this case, it would be 8 squared plus 2 squared. Is b confusing because now my b is where the c is? Or are you okay that a squared plus b squared equals c squared? The c squared is always the hypotenuse, doesn't matter what letters they are, right? Who decided on using a, b, and c? Maybe there's another country that says, oh, we always learned f squared plus g squared equals h squared, because h is hypotenuse. I don't know, doesn't really matter. But this is our hypotenuse, that's what I want to solve for. I had chosen b because I used blue for color. Okay? Now, 64 plus 4, this is going to be 68 equals b squared. And how do you get rid of a squared? Square root. Okay? Is the square root of 68 something you can do easily in mental math? No. Could you estimate it? What would it be close to? Close to 8, because you know square root of 64 is 8. Okay, it's good to get mental math. I'm going to label this right here. When you can't simplify something, that's an exact number. In mathematics, we're going to start leaving things as exact numbers because they don't cause us problems that rounding does. Okay? This, if I go to my calculator and I actually see how close to 8 is it? 8.246. As soon as you write a decimal, it's going to get rounded somewhere. Whether you use 8 decimal places, this number actually has decimal places that continue on forever. Call that an irrational number. If we use decimals and then we retype it, we're rounding. In grade 10 math, if you round early and it causes your final answer to be off by a decimal place, you will lose marks for accuracy. So generally, we don't want to round early. Sometimes then, it's easier to use exact numbers rather than decimals. So what I'm going to do in this case is I'm just going to label this, now that I've figured it out, as the square root of 68, instead of writing all those decimal places. Exact numbers are sometimes nice because you also have to write less, because the decimals go on for a long time. Okay? So we found the blue slant height, and now we can find the blue area. Right? How do we find, I'll turn my calculator up. How do we find area of a triangle? We go base. Okay. We'll find this area, and then we'll go down, and we'll be perfectly timed. So we do base times height, and I write in the exact value right into my calculator. I have to use the arrow key to get out of the square root, divided by 2. I get 24.73. So I'm going to write that in purple. Of course, that's rounded. If I had wanted to leave this, I could have done base, which is 6, divided by 2, which is 3. This is going to equal 6 divided by 2 is 3. 3 times root 68 is the exact number. If I go back to my calculator here and I just double check that, 3 times root 68, does it come out to the same number? Yes, it does. So I kind of like the exact value, but it's not wrong to have the decimal place here. I even made a mistake when I rounded it. Did you see that it should be 3.74? We'll pause the video here. We'll go ride a bus. So we have to do the same thing with the green dotted line. So I'm going to change my color of pen here. To green, because we need to find that green slant height. And it's going to be exactly the same idea. So we look. we look to our original picture, and we've got a triangle with the green one as well. But now, the base of the green one is half of the 6th side. So the base of the green one will be 3. The height is 8. And this time I'm going to use G because I'm finding the green. Now, normally when you don't know something in math, we generally go to X first. But if you're ever in a question that you're finding more than one thing, you can't use X again because you already decided X was one thing. You'd have to pick a different letter for the other one. You could pick Y. That's usually the letter that gets picked next. Not a problem. In this case, I picked letters based on the colors I was using. So I'm going to have, same idea, 8 squared plus 3 squared equals G squared. 64 plus 9 is 73. If we went to our calculator and actually figured that out, 8.544. But once again, I'm going to go up to here, and I'm going to label square root of 73. Technically, I'm going to go back to my blue pen here. I could say, well, since these are the same, this would also be the square root of 68. And since I already figured out this one was 3 root 68, I'm going to write 3 root 68 there as well. So now we still also have to find the area of the green section. So once again, I would go to my calculator. The base of that one is 4 times by the square root of 73, and then that will get divided by 2. Mathematically, when you're multiplying and dividing, you see that you could do the 4 divided by 2 right away. So if I had a non-calculator part of this question, I would say, well, 4 divided by 2 is 2. So I know that my area of this section, that's my exact. If I push enter on my calculator here, I'm going to find out what it is, rounded 17.088. So that means down here, this section will also be 2 square root of 73. So we did our net, and now we have solved all 5 of those areas. So we're ready to solve the whole thing to the nearest square meter. I'll keep it in purple. So our surface area will equal 24 plus, I'm going to take a look at my numbers. I'm going to write it exact first. We have 3 root 68 and 2 root 73. 3 root 68 plus another 3 root 68s on the other side, plus 2 root 73s for the one, plus another 2 root 73s for the other one. And we haven't learned this yet, because we have a whole unit on square roots coming up, but I think the idea is going to be pretty easy for you. For example, last year you learned polynomials. In polynomials, you learned that 3x plus 4x would equal 7x. Probably after grade 9, now you think that's an actually easy concept. We can apply that concept here. Does it make sense to you if you had 3 root 68s and you added another 3 root 68s, that you would get 6 root 68s? And if you had 2 root 73s and you added another 2 root 73s, you would have 4 root 73s. Okay? In university, lots of university math classes say no calculators whatsoever for final exams. So if it was a university class, this is how you would end your question. And of course, you would add units. We are in grade 10 pre-calculus, and this question said to the nearest meter. So now I'm going to go to my calculator and type this in. 24 plus 6 square roots of 68 plus 4 square roots of 73. I'm going to push enter, and it gives me 107.65. You should also be having your calculator out, and whenever we're doing calculations, try to do them first on your own, because certain calculators leave things in square roots, so I want to show you where that button is to change it. If you don't know where that is. So to the nearest meter, okay, and if I was showing my work on a quiz or on a test, I would probably first show a bunch of decimal places, 107.653. And then, notice, and everything in this question was in meters, so my units in the end will be meters squared. Also, a really nice thing to start getting used to is if you have a final answer and you're convinced you're done, you've got your final answer, put a box or a circle around that answer to show that that's your final answer. Now we're going to talk a little bit about style and answering math questions and being organized. So I'm going to take this whole question and look at all the work that we did. There was a fair bit of work in this question, and we're going to get questions that require a lot of work. So we want to be organized and have style a little bit, because if we're unorganized, our chances of making a mistake or grabbing a wrong number just increase a lot. So part of what we're doing in this question is trying to keep our work organized. I did that a little bit with the colors, right? But usually you write a test only with pencil. Notice I had a little explanation of what I was going to do, right? It doesn't have to be big, but I'm like, I'm going to find this slant height first. That sometimes helps me later, because sometimes you do math, and by the time you finish the math part, you're like, where was I? What was I doing? I don't remember what my plan was. So the little label is like, oh yeah, I was finding the blue slant height. That helped me get these two areas. Then I had a section where I found the green slant height. I labeled things as I went along, and then I found my total surface area by adding up all 5. And I showed all my work all the way through. Use lots of paper for math. If you're worried about running out of paper, I have extra loose leaf if you need it. Spacing things out helps you see things better, and you'll also make less mistakes. So take time, make it organized, make it neat in your own writing. Like some people have neat handwriting, some people it's like, yeah, my handwriting is not neat, but you can still make it neat within your own style of writing by just using more space. Right? If your writing is messy, no reason to have it messy and also have it overlap. The overlap is your choice. You can use more space. No matter how neat or how messy your writing is, you can make it organized. And by having that style, you're going to find you make less mistakes, and then you'll start to feel that, hey, I'm better at this now. One of the things, let me zoom back, maybe at the top of this question, maybe you want to just write a note. This is a special kind of question where we had to do extra work, where we had to find the slant height. This kind of question is going to come up a fair bit. So maybe you want to label it in this question, because this will be one you're going to go back and study and practice a little bit more, because it's a little bit more involved. None of the steps were hard, but when we have a question with 10 easy steps, it's naturally harder just because there's more things you have to remember to do. All right, and now you can see why, with 5 minutes left in class, I decided yesterday this wasn't a good question to just do in a little bit of time. It's going to take some time. Okay, and with that, we move on. I'm going to talk a little bit about this formula, because the reason this formula, we don't use it, but the reason it's important is for finding the surface area of a cone. So, what happens in the surface area of a regular polygon is that you end up with a bunch of triangles that you have to do base times height, and the height is the slant height. And if you added all of those bases together, you just get 1/2 S times the perimeter. And this is a 6-sided shape. And the idea is, what if we kept adding sides, right? Started with 4, and then we went to 6 here. Now this one looks like it has like 12. And then I could go 200 sides. On a regular polygon, if it has more and more sides, what shape is it getting closer and closer to? A circle. Okay? For example, there are some things in life that you know the shape of. What is the shape of a quarter? A circle. What is the shape of a dime? A circle. A loonie. No. Take a look the next time you get a loonie. It's not a circle. It is an 11-sided polygon. I don't, like 11 is a day where like, let's do something weird with the loonie, besides just calling it the loonie. Let's make it have 11 sides. But already at 11 sides, when you hold it in your hand, you think circle. So I'm very happy you said circle, because that's the answer I wanted you to say. Thank you. But it has 11 sides. If you went to 200 sides on a polygon, they'd be so tiny that it's basically a circle. But if we take that formula, this is exciting math, and you say that the lateral area of that previous one was 1/2 the slant height times the perimeter of the base, the perimeter of a circle is just 2 pi r. So the lateral area, this part in blue, without the base, is just 1/2 times the slant height times 2 pi r, and the 2's nicely cancel out. So we just have S times pi r, and we write it as pi r s. You have your radius, your slant height, times by pi. And the whole surface area of a cone also then adds the circle that's the base. So again, I could have just shown you this formula and we could use it. But now we see the mathematics behind how mathematicians came up with the formula. All formulas in math make sense from basic math somehow. A lot of formulas, right? Like a squared plus b squared equals c squared. Why does that work? Something you could try to figure out. It's probably the most famous formula because people have figured out how it works, I think, hundreds of different ways. There's the most proofs of that formula of anyone. But it could be something you decide to try. Why does a squared plus b squared equals c squared? Do you have a reason why it works? Anyways, look it up, try to figure it out. Here's our first question. A right cone has a base radius of 4 and a height of 10. So when drawing a cone, draw an oval for the circle that's on the bottom for 3 dimensions. Pick a point at the top and connect it. Some people like to then go back and take out their eraser and make the backside dotted because you can't actually see it. Then when we go to label things here, the height goes from the center of the circle up. So this is 10 meters. The radius is from the center out. One of the things you have to be careful in questions with circles is whether they tell you the radius or the diameter. Diameter goes all the way across. In questions where you have formulas that are nice to use, start by writing out the formula. So pi rs plus pi r squared. Then plug in everything you know. And we have a problem here, okay? We know the radius, but I have to leave a blank there. I don't know the slant height. This is another one. This comes up so often. I'm going to put this above this question again, okay? Because you will be tempted to put what number in here? 10. So it's like, oh, I need to put in another number. The only other number I know is 10. I should plug it in. And then we're going to run into problems. So I could plug in, oops, radius is 4. So I need to find and how do I find the slant height? Well, I made a nice triangle here where I know this is 10, this is 4. Call that x. A squared plus b squared equals x squared. 100 plus 16. And I would keep the exact number. For one, it's going to be easier to type into your calculator. So I'm going to put right here square root of 116. Because then I can go to my calculator. Need to find our pi button, because we don't want to use 3.14, because that means we're rounding early. Pi times the square root of 116.
Sorry for the interruption. This is a reminder to all semester 1 hockey students. The bus leaves at 10:55 from the east door parking lot.
Are you okay that I put the 116 in first and 4 second? Do you know when you multiply things, the order doesn't matter? Good. So 2 times 3 is the same as 3 times 2. Go back to my calculator. Plus pi times 4 squared. Enter. 185.609. Again. I'm going to change to squiggle brackets because as soon as I write decimals, I've rounded. And the final thing you need to do in any question is check, did they ask you to round something? Yes, nearest square meter. So I need to take the time to round this up to the nearest square meter. I need to check, did I include my units in my final answer? Not yet. What was I using? Meters. What are we finding? Area, meters squared. Then I'll put a box around that final answer. So one of the most important things that you do when you finish a question is to reread the question again to make sure you didn't miss it.
If you are applying like rounding to the nearest meter, you still need to squiggle.
Yes, because this is an approximation method, right? So whenever we're approximating something, we should write that squiggle to have it down. Okay, again, we're just about to get to the end of this section, so the homework on page 34 you can get a good start on.